Example 1.4, part A we have completed. We'll go for part B now. Estimate the accelerations of electron and proton due to the electrical force of their mutual attraction when they are 1 angstrom apart. Okay. Separation is 1 electron. Estimate the acceleration of electron as well as proton. Okay, first we'll go for electrostatic force. This we already calculated. F equal to K E square by R square. So charge is 1.6 into 10 to the power minus 19 whole square. Separation is 10 to the power minus 10 whole square. So you are getting 2.3 10 to the power minus 8. This is electrostatic force. What is the acceleration of the proton and electron? That is the question. Okay. Now, let us take if the ratio of electron to proton also we got it, that is 10 to the power 36. Question, we have to find the acceleration of the electron. What we will do? By using electrostatic force expression, F equal to 2.3 10 to the power minus 8 we got. Now we'll use Newton's second law. F is also equal to mv. Force value already known to us. F equal to m into a. For to find acceleration of the electron, F equal to mv into AE is equal to F by mv. Electrostatic force is 2.3 10 to the power minus 8 divided by mass of the electron, that is 9.1 into 10 to the power minus 31. So if you simplify, you will get acceleration of the electron as 2.5 into 10 to the power 22 meter per second square. Now we have to go for acceleration of proton. That is again same formula. Force, electrostatic force is 2.3 10 to the power minus 8. F equal to ma. A of proton equal to F by mass of proton. Previous case we have calculated acceleration of electron. Therefore, mass of electron. Now we will take mass of proton. If you simplify, you are getting 1.4 into 10 to the power 19 meter per second square. Now you compare just acceleration of electron with acceleration of proton. What you can say? Acceleration of electron is very high as compared to acceleration of proton because mass of the proton is higher as compared to electron. So, as mass decreases, acceleration increases.